Hello everyone and welcome to my basement. Yes, I bought a whiteboard so I can do video lectures while I'm off on paternity leave. So here we go. Here's the first video lecture from my basement here. So what we're going to talk about in this video is Newton's law of cooling. And that's a hard word for me to say. I don't know why I struggle saying cooling. But yeah, Newton's law of cooling. And what it deals with. This is kind of, for lack of a better word, I think it's kind of cool. No pun intended. Because it's obviously applicable to real world scenarios, and you can use Newton's law of cooling when you're trying to determine how long something has been cooling, such as, let's say, a dead body. That's the one I like. I think that's the most fun to think about, not to be morbid or anything. But so if you've ever seen a crime show, a lot of times they'll show the forensic examiner, or whatever you want to call it, coroner. They'll get there and then they'll stick a liver probe in the dead body when they get to a murder scene or just someplace where somebody's died. They stick a liver probe in to determine the temperature of the body now. And they can use Newton's law of cooling, work backwards, and figure out when that person died, what the time of death was. Now, today it's not going to be as interesting. We're going to talk about how an egg can cool, being boiled. I think maybe next video might be a cake or something, maybe another egg. I'm not really sure, but just anything that cools in real life, you can determine how long it has been cooling. All right, so that's the idea, among other things. So here we go. Let's get started. So this is the formula. T of T is equal to T sub m plus T sub 0 minus T sub m in parentheses times e to the negative kt. All right, so I'm going to explain what all these mean. So T sub m is the temperature of the surrounding medium. A lot of times you'll see it written as T sub e, the temperature of the environment. So for example, again, how about we just use a cake example? So let's say you pull a cake out of the oven. Then T sub m is going to represent the room temperature. All right, you pull it out, now it's just sitting in the room, and that's the room temperature. It's the temperature of the surrounding environment. The example we're about to do is going to be an egg example where we place it in cool water. So it's going to be the temperature of the water is what that represents. Okay, or if you deal with a dead body, let's say you find a dead body outside. The temperature of the medium is just the temperature outside. So that's the idea. It's the temperature of the medium or the temperature of the environment. All right, let's keep going. T sub 0 is the initial temperature. It's just what the thing started at. So again, if we're dealing with a dead body, then usually they use 98.6 as an initial temperature. Is what the temperature was before it started to cool. All right, that's the idea. And then K is just going to be some constant. This is what a lot of people struggle with. K is a constant. That varies depending on what you're dealing with. So if you think about it, an egg is going to cool differently than a dead body would, or a dead body is going to cool differently than, let's say, coffee, hot coffee, that kind of thing. So depending on what you have, that's what's going to vary. And most of the time, you're going to have to find that K. All right. So a lot of these problems are going to require you to make two equations. The first one to find K, and then the second one a big picture equation to figure out how long something has been cooling. All right, how long it will take to get to a certain temperature or something like that. All right, so with that being said, in this video I just want to do one example, and hopefully again, this is the first video I've done, so hopefully I run through without any hitches. Actually, this is the second video. I've already messed up. I had to erase a video, but let's get it started. Okay, so I've got this written on the other side. Look at this. All right. I won't tell you how much money I spent on this. Okay, so a hard-boiled egg at temperature 96 degrees Celsius is placed in 16 degrees Celsius water to cool. 4 minutes later, the temperature of the egg is 45 degrees Celsius. Determine when the egg will be 20 degrees Celsius. Okay, so you guys write this down. Make sure you get this written because I am going to erase this. So yeah, pause the video now, write it down, and yeah, I'm going to flip back to the other side to get this thing started. All right, here we go. So we're trying to determine when the egg will be 20 degrees Celsius. All right, that's the idea. So make sure you refer to this, guys, as I talk about it, okay? So you should have it written down. When I ask you things, look at the question to be able to come up with the answers. All right, so let me get rid of this. I'll leave Newton's law up there. Okay, so there's Newton's law, and like I was saying earlier, what you're gonna need is you're gonna need two equations. Now I've done plenty of these, so I know that going into it, but when we do some examples, you guys will see why. All right, so here we go. So I'm gonna say the big picture is what I'm gonna do on this side. On the other side, I'm going to do the K equation. That equation is gonna be to find K. All right, so let's start with the big picture equation. So if you think about it, not a lot of thought goes into it, so let's go ahead and get started here. You just have to start filling in some values. I want to use Newton's law of cooling, all right? I need to try to fill this in because I've got a hard-boiled egg that is cooling. It starts at 96 degrees and it's placed in 16 degrees Celsius water. It says determine when the egg will be 20 degrees Celsius. All right, so let's start filling some things in. I'm not going to rewrite the formula, but and again, you don't have to. You don't have to memorize this formula. You'll be given this. So here we go. Let's get started. So before I fill this in, T of T, let's fill T sub M. Now remember, T sub M is the temperature of the medium. So what is the temperature of the medium or the surrounding environment? Well, if you remember, we placed this egg in water. Okay, well what was the temperature of the water? Well, the answer is 16 degrees. So I put 16 in for T sub M. Just trying to fill in what we can. All right, now ask yourself, what is the initial temperature of the egg before it starts to cool? That's right, 96 degrees. That's T sub 0. All right, I filled that in. Now I need to fill in T sub M again. Well, that's easy. We've already written it. It's 16. And then times E to the negative KT. Well, the question is, do I know K? The answer is no. That's what I'm going to have to find. I have to find K first. And the other thing is, do I know T? Well, if you guys read the question, it says determine when the egg will be 20 degrees Celsius. So I don't know that. I'm trying to figure out T as well. So hopefully you guys see the issue here. I've got two variables. I've got K and T that I need to find. I need to find both of them. So if I've got two variables, I'm going to have two equations to solve for them. So that's the reason why. And there's one thing I'm forgetting, what my T of T is. So again, let me read that last sentence one more time. It says determine when the egg will be 20 degrees Celsius. So the temperature after a certain amount of time, again, I don't know what that time is going to be, but the temperature after a certain amount of time, we want that to be 20. All right, so that is the big picture equation. All right, so I'm not going to erase that. I'm going to leave that up there because I'm going to come back to it. I want to be able to find K, and so T is my only variable. All right, that's what I want. I want to get K, so T is my only variable. So just give me a second. Let me erase this backside here. Might be a good place to fast forward the video. For some reason, this backside is a little bit harder to erase. All right, that's good enough. Let me flip it over now. That's good enough here. So here we go. K equation. There we go. All right, so let me write it down up here. K equation. All right, now, if you notice, reading through, I want you guys to read through the question again. Read through it. And I want you guys to look to see what other information do they give us that we haven't used yet. Okay? And that's the stuff that we're going to need to use to be able to figure out what K is. So again, let me write down Newton's law of cooling. So it's T of T is is equal to, you still have to use Newton's law of cooling here, guys. T of m plus T sub 0 minus T sub m times e to the negative kt. All right, so I've got that written down. Now I'm going to start filling some stuff in again. Well, again, the temperature of the medium doesn't change. That's the same. We put this egg into 16 degrees Celsius water, so that's 16 still. The initial temperature doesn't change. It is still 96. And I'm going to go and fill this 96 minus 16 times e to the negative kt. Now here's where I'm going to pause. Again, k is the variable I want to solve for, so that's still going to be a variable. But what could our time be? So if you think about it, read that second sentence. All right, if you haven't noticed it already, it says 4 minutes later, the temperature of the egg is 45 degrees Celsius. So it gives you a time. It gives you 4. All right, so let's plug in 4. So it's going to be 4K up here. So it's going to be e to the negative 4K. All I did was I plugged 4 in for time, and then I just changed the order because it's commutative. Multiplication is commutative. And so again, let me read that one sentence again. It says 4 minutes later, the temperature of the egg is 45 degrees Celsius. So wouldn't your temperature after 4 seconds be 45? So that's what I'm going to fill in here. So now I have a new T of T with this K equation. So look at what we have. Again, they gave you that extra sentence there so you could figure out what your constant's going to be. You have to have more information to be able to figure out what that K is. All right, so hopefully that makes sense. I filled in, like I said, 4 minutes later, that's my time. My temperature after 4 minutes later was 45. All right, so let's go ahead and try to solve it. We should be able to solve this using what we know, what we learned in section 3.5, solving exponential equations. Here we go. I'm going to simplify first. 96 minus 16 is 80. Not 18. This is 45 here. All right, so let's take it one step at a time. I want to get k by itself. I want to isolate the variable. Wouldn't it make sense to get rid of this first? So I'm going to subtract 16. And I was unprepared here, guys. I forgot to bring a calculator. Dang it. All right, well, we'll go ahead and get this thing going. I might have to take a break and go grab a calculator. But here, let's go ahead and keep going. 45 minus 16, I don't think I need a calculator for that. I think it's 29. 29 is equal to 80 times e to the negative 4k. All right. I'm going to pause the video. Hopefully it doesn't take me too long. I'm going to go grab a calculator. I'm not doing another video here. I'm going to go ahead and keep going with it.